In this final part 3 of the lesson series on our place in the universe, we'll expand our perspective even more and learn that our own galaxy, the Milky Way galaxy, is situated in a much larger universe. So again, we've learned that planets orbit stars, and we call that a solar system. Galaxies are giant collections of stars and their planets, all bound by gravity. In this diagram, we see our Milky Way galaxy, and then we see some of our closest neighboring galaxies. So the Milky Way is not the only galaxy in the universe. These two over here are called the Magellanic Clouds, and these are some of our closest galactic neighbors. For us in the northern hemisphere, we can't see them in the night sky. You have to go to the southern hemisphere. But down in Chile, you can see the Magellanic Clouds, the small and the large Magellanic Cloud. They are separate clusters of stars outside of our own Milky Way galaxy. In this picture, panorama, we see the Milky Way and the Magellanic Clouds in one shot. Now in this diagram, here's our Milky Way again, and now our Magellanic Clouds are shown as these small little splotches here. But now we're widening our perspective to include another galactic neighbor, the Andromeda Galaxy. The Andromeda Galaxy is about 2.5 million light years away. So it would take light 2.5 million years to get to the Andromeda Galaxy. Because it's so far away, it appears as a small splotch in the night sky. Here's the Andromeda Galaxy. Now, for a long time, scientists didn't know whether this little splotch, this fuzzy, what they called a nebula, in the sky was within our galaxy or was outside of our galaxy. And this was a tremendous discovery, that the Andromeda Nebula was really a galaxy, a separate galaxy. Here's another picture of it, again using sort of a small lens, but when you put a small telescope on your camera, you can get a picture like this. Now, when you use a really big telescope like the Hubble Space Telescope, you can see tremendous detail in the Andromeda Galaxy. This picture was taken by Hubble, and it's a zoomable picture. So here is the core of the Andromeda over here on the left side, and then here are outer portions of the galaxy. What I'm going to do is zoom in here slowly, and we're going to see more and more stars come into view. So each of these little splotches of light is a star. So when we look at a galaxy from far away, it appears to have just sort of, whatever this is, the uniform brightness, but it's actually the combined light of billions and billions of stars. So it's instruments like the Hubble telescope that have dramatically increased the scale of our universe. The Hubble telescope was put in space in order to avoid the distortions of the Earth's atmosphere. It's named after Edwin Hubble, who was an astronomer in the early 1900s, and he made very important discoveries about the nature of our universe. But now I'll just tell briefly the story of what they did with the Hubble telescope back in the 1990s and again in the early 2000s. They pointed the Hubble telescope at a tiny little piece of the night sky that appeared to have nothing there. So it was just sort of empty space as far as anyone knew. They took a very long exposure of that tiny spot in the sky. And what emerged in the photograph rocked the astronomical world. It's called the Hubble Ultra Deep Field Image. And what they found were 10,000 galaxies in a tiny patch of sky that appeared to be empty space. So here is the image, and every one of these splotches of light is a galaxy, with the exception of a couple of local stars in our Milky Way galaxy, the ones that appear to have these sort of little spikes called diffraction spikes. All the rest of these little splotches of light are galaxies. And again, to the naked eye, it appeared to be empty space. But with the Hubble revealed the existence of thousands and thousands of galaxies. Now, the smallest red galaxies are the farthest away galaxies, and they're approaching 13 billion light years away. The brighter, more defined galaxies were the closer galaxies. So in looking at this one image, we are looking back in time as well. So here we see the light from these galaxies as the light left just a few billion years ago, whereas the light from these very distant galaxies left those galaxies 12, 13 billion years ago. Now here's the important discovery that Hubble made back in the 1920s. He discovered that galaxies are moving away from our galaxy, and the farther the galaxy, the faster its velocity. So again, galaxies that were relatively closer to us were moving away from us, but at a slower speed compared to galaxies that were farther away, and then galaxies that were really far away. The farthest galaxies were moving the fastest. The closer galaxies were also moving away, but at a slower velocity. So it seemed that all the galaxies were moving away from us. And that raised the possibility that in fact the entire universe might be expanding. And this led then to this concept of an expanding universe. So a diagram like this is often used to depict the expansion of our universe. We have a balloon here shown to be inflated over time. On the surface of the balloon we have galaxies. Now it's sort of weird to think about this, but the concept here is that our entire three-dimensional universe is now sort of painted on the surface of the balloon. The key point, though, is as you blow up the balloon, the surface stretches, and so the galaxies will be moving away from each other. And the surface of the balloon, the rubber of the balloon, represents space in the analogy with the universe. So scientists argue that the universe is expanding because space itself is expanding and carrying these galaxies along with it. As space expands, galaxies are receding from each other, moving away from each other. There is no center to the universe. From the point of view of any particular galaxy, all the other galaxies are moving away. Now, this idea that galaxies are moving away now led to the inference that, well, in the past, the galaxies must have been closer together, and further back in time, even closer together. And it led to the idea that the universe might have had an origin, a beginning, and this came to be known as the Big Bang Theory. As it turns out, there is a galaxy that is approaching us, and it is none other than the Andromeda Galaxy. And you might say, well, how's the Andromeda Galaxy moving towards us if all the other galaxies are moving away? Well, we are close enough together that the gravitational force can overpower, in a sense, the expanding force of the universe. So Andromeda and the Milky Way are on a collision course, and in several billion years they will collide. It is an amazing thing to think about, that in one tiny patch of the night sky that appears to have nothing, there are thousands and thousands of galaxies. And if you multiply that out across the whole surface of the night sky, you come to an estimate of hundreds of billions of galaxies in our universe. To get a handle on that, take a look at this cube. Let's imagine this cube is our universe. Then each one of these little dots would be a galaxy. But to get a sense of that, let's imagine now the cube is the size of a classroom. The little dots would be the size of a speck of dust. So the relative size of a speck of dust to a classroom is in the same proportion as a galaxy to the entire universe. With so many stars in our galaxy and so many galaxies in the universe, it does raise a question: is there anybody out there? So we know of one intelligent civilization in our galaxy, in our universe. Could there be others? And scientists are busy right now trying to detect signals from other potentially intelligent civilizations in our galaxy. And if we do discover other intelligent civilizations in our galaxy, it really will be an incredible human achievement. In comparison with other species, then, the factor that caused our success can be seen in this picture: our enlarged brains. And so we can think that it really is a sort of a privilege to be a member of a species with the capacity to work out our own position in this giant cosmos, and a little bit about the history out of which we emerged. Of course, other creatures have great discoveries as well. But in comparison, the achievement of our species to work out that we exist on a planet orbiting a star within a giant galaxy that is one among hundreds of billions of other galaxies in our universe, that really does inspire awe, and it is something that we can be proud of.